Okay, I had several people gone for class today, and I want to make a quick little video to explain basically what we learned today. Okay, and these are the notes. You can find the notes online. I'm not going to spend a heck of a lot of time. I'm not going to rewrite all the notes. I'm going to hit some key points. Okay, the key things to get out of today are the relationship between work and energy and the different forms of energy. Okay, so work and energy are almost the same thing. Okay, energy is the ability to cause change. Work is actually causing change. When you do work on an object, you cause it to gain energy. Okay, that is what this says. When work is done on an object, it gains energy. Okay, and in fact, we can say a little bit more than that. The work done is equal to the energy gained. I'm going to go ahead and put that in here. Work done equals energy gained. That's the law of conservation of energy. Since work is the transfer of energy, okay, we can't create it, we can't destroy it, so whatever you use is still there. One object gains it, you lose it. Work done equals energy gained. Now, there are multiple forms of energy. Okay, so how do you recognize if something's actually gained energy? There's a couple things to look for. Okay, one of them that's subtle, we don't see very often, but we have to keep in mind, is we can look for an increase in thermal energy. Thermal energy we usually think of as temperature, heat. Okay, generally that's okay. If you do work on an object and it gains thermal energy, then it generally increases in temperature. Okay, and you guys sometimes do work for the express purpose of getting thermal energy. If you rub your hands together because they're cold, you're doing work to generate heat. Okay, the work done is equal to the energy gained. Okay, now thermal energy is only with atoms, right? Atoms move faster, spread out, they gain thermal energy. They move slower, cool down, condense, they've lost thermal energy. Okay, we're not real interested in mechanical energy right now, or sorry, in thermal energy right now. Okay, this is the energy of atoms, and we looked at all that stuff last semester, and endothermic and exothermic reactions, endothermic, exothermic phase changes, and it is something we have to keep in mind. Okay, frictions is that force that opposes motion, and the way friction opposes motion is by taking the energy that we're trying to use and turning it into heat, turning it into thermal energy. Okay. Now, some other types of energy. Energy of objects is mechanical energy. There's two major kinds of mechanical energy. There's energy due to motion and energy due to other forces that are acting on it. Energy due to motion is called kinetic energy, and we have talked about this before. This is a big deal. Okay, kinetic energy equals 1/2 mv squared. Okay, so making something go faster increases its kinetic energy. Having something with more mass means it'll have more kinetic energy. Velocity is squared. What that means is velocity has a bigger effect than mass. If you double something's mass, you double its kinetic energy. If you double something's velocity, you quadruple its kinetic energy. 2 squared is 4. Okay, but kinetic energy is just one kind of kinetic energy, and just like before, okay, you can do work to increase temperature, you can do work to increase speed. So the work done, if it all goes into kinetic energy, is equal to the change in kinetic energy of the object. Of course, mechanical energy is also got potential energy in it. Okay, that's what this slide's about. Potential energy is energy stored due to a force, and I want you to think about that. Okay, we talked about chemical potential energy, which happens when atoms form bonds. And atoms form bonds because electrons out here and electrons right here, they're in the same basic spot, and the protons here are attracted, and these protons are attracted. There's an attractive force holding these together, and it's got chemical potential energy. Okay, so this force is causing some energy. If you stretch a spring out, right? You pull it this way, the spring pulls back this way. If you let go, it's going to snap back. It's storing some energy. But the biggest one we worry about is the one from gravity. When you lift an object up, it now has the ability to fall, or it has the potential to fall. Okay, so gravity is a force that pulls things down or together, and it causes gravitational potential energy, which we abbreviate PE. Okay, and this equation should make perfect sense. Potential energy depends on mass, g, the acceleration due to gravity, and height. When you do work to lift an object, you have to do work against gravity. You have to lift its weight. Well, mass times the acceleration due to gravity is weight, and the higher you lift it, the more work is done. Okay? Well, this is a force times a distance. This is work. potential energy equals the potential energy of an object is equal to the work done to lift it, or mgh. Okay, so yet again we see this relationship that potential energy or energy transferred is equal to work done. Okay. There are a few example problems in the notes you can go through and look at, but basically there are a few major things to take away from today's notes. The first thing is work done equals energy transferred. Okay, so the more work you do, the more energy is transferred. Work done equals energy transferred. And what this means is this is going to cause one of three things is going to happen, or some combination of all three. So it's going to cause an increase in either thermal energy, and you'll measure that with temperature. Okay, so temp will go up. It could cause an increase in kinetic energy, and you'll measure that by seeing an increase in velocity, so the speed goes up. Or you'll see an increase in potential energy, and if potential energy increases, then it's higher than it used to be. Okay, so these are the three things to look for. When work is done, energy is transferred. The object is either going to be warmer, it's either going to be moving faster, or it's going to be higher. Okay, now the other thing to keep in mind is you can calculate how much energy is transferred by calculating how much work is done. Okay, so if you know a certain job takes 3,000 joules of work to get done, then you know that the energy transferred is 3,000 joules, right? So work and energy have the same units. Okay? Take a look at the notes. Take a look at the worksheet in eBackpack, and good luck. It's not a huge concept, not a lot of new stuff today. We're just putting in some little more details about energy. Okay?